section 1.2b, we're going to start talking algebraic stuff, gathering like terms, knowing what a term is, what a coefficient is, and so forth. So we can list anything. Let's just say like terms, guys, are when your variable and its exponent match. When your variable and its exponent match. So for example, 4x squared and 3x squared. Why are those like terms? Well, what do they both have for their variable and exponent? They both have that x squared feature. The coefficients, the number in front, that 4 and that 3, they do not have to match, okay? So it's just the variables. Another one, let's do 5xy and 8xy. And you guys notice that they both have the xy. And let's do like one, well, we'll do two more because one's really easy. We'll do this one. Negative 4 c squared d to the 4th and c squared d to the 4th. And what you'll notice is that second term doesn't have a number in front, so its coefficients to be assumed 1, okay? So that's negative 4 c squared d to the 4th, and that other term's technically 1 c squared d to the 4th. But what we want to notice is they both have not only c's and d's, but the c's and d's are raised to the same power, all right? The last one I want to put on here is just 6 and negative 4. Those are considered like terms because their variable is non-existent. They're just numbers, but numbers will always be like terms. All right, so how do you combine them? All you do is focus on the number in front, the coefficients, and do the math with the coefficients and leave the variable the same. So what we're going to do is we're going to add or subtract the coefficient. Add or subtract the coefficients, so those are the numbers in front. And keep variables and exponents the same. So when you're combining them by addition or subtraction, we are not raising it to x to the 4th. It's how many x squareds do you have in this hand? How many x squareds do you in this hand? Okay, we have 5 x squareds all together. All right? So let's do the combination. I'll give you the math. Let's do the 3 up top, those 3 pairs I listed. Let's do the first one with addition. So example 1. What would be 4x squared plus 3x squared? 7x squared, right? And that's where sometimes I'm actually kind of glad that I have like this review with you, because a lot of people want to make it like 7x to the 4th or something. They want to do something with that variable. They want to do something with that exponent. But what we're going to do is we're going to add those coefficients. So we're going to add 4 and 3, but then we're going to keep the variable and the exponents x squared the same. So that's just 7x squared. Let's subtract example 2. So let's do 5xy minus 8xy. You got it. Negative 3 what? Negative 3 xy. You got it. So we're going to focus on that number, 5 minus 8, which is negative 3, but then realize they both have that xy in common, so that will tag along with them. Is that all right? And then last but not least, let's add example 3. So we'll do negative 4c squared d to the 4th plus c squared d to the 4th. That second term, what did I say his hidden coefficient was? 1. Some teachers might not like it. I don't care if you throw a 1 in there. Like if you want to make that an obvious 1 for your coefficient, throw a 1 in there if you want to. So negative 4 plus 1 was like get us to negative 3. Negative 3 c squared d to the 4th. And again, notice we did absolutely nothing to those variables. We just said, okay, they both have these, so that's how many of those we have total. Is that all right? Okay, so that's addition and subtraction. Then we're going to get into multiplying them, so we need to know the rules of exponents and what happens when you multiply them. So let's look at this next one. It says, what is the expanded form of n to the fifth? Remember, exponents are just a shortened way to show multiplication repeatedly, okay? So n to the fifth, guys, is n times n times n times n times n. You are multiplying that base, okay? So that's called the base, n, as many times as that exponent says, all right? So how do we do n to the third times n to the fifth? Well, let me show you the long way to do it. What you would do is you would take n to the third, which is n times n times n, and you would multiply it by n to the fifth, which was the 5 n's. But you notice then at that point you just have a giant exponential problem. How many n's are you multiplying now? 1, 2, 3, 4, 5, 6, 7, 8. You got it. So that's just n to the 8th. You guys see what I did? So I just said, okay, we know the expanded version of n to the fifth is 5 n's in a row. So that means the expanded version of n to the 3 is 3 n's in a row. So when we multiply them, we end up having 8 n's in a row, which is n to the 8th. So what's a quicker way we could have done with 3 and 5 to get 8? What can you do with 3 and 5 to get 8? Add them, right? So all we need to do is just add the exponents. So whenever you're multiplying terms, you're going to keep the base the same, but you're going to add the exponents. All right? So the generic rule, we always have to do it generically, right? A to the m times a to the n will mean you only write the base once, right? Like we had a bunch of n's here, but we only wrote n once. So we're just going to write a once. But what did you just tell me, Braden? What do we need to do with the exponents? Add them. So there's the rule. We just discovered the rule, right? So that a will stay the base, like n will stay our base, but we'll just say how many n's total we have, and that will be our exponent, m plus n. All right, so here's a couple. Let's do, I have like 4 on here. Let's do example 1. Let's figure out what y to the 4th times y to the 6th is. Example 1 is y to the 4th times y to the 6th. What do you guys get when you do that? Is that okay? And I'm not expecting you to even like show work. Like some people think they have to show this, 4 plus 6 to get the 10. I know that once you know the rule, we're just adding them, right? So that's just y to the 10th. We can like square that in. Let's do example 2. What if I give you c to the 8th times c to the 2nd? It's a trick question, right?
Oh, wait.
It looks 10, right?
Yeah.
But do you guys notice that we have this middle c in the middle?
Right.
What is his exponent if we don't put it? It's just 1, right? Because there's only one c there. So really this is c to what power? C to the 11th. Okay? So remember when your coefficient isn't listed, it's assumed to be 1. If your exponent's not listed, it's assumed to be 1. Okay? So if it's hidden, it's usually 1. Let's like spice it up by giving you some coefficients. What if we do 4x to the 5th times 3x to the 7th? Do you remember what you do there? So example 3 is 4x to the 5th times 3x to the 7th. So on these other ones, we were not really focusing on the coefficients, but we're just going to do the math with the coefficients. What's 4 times 3? 12. So that's 12. And then what is x to the 5th times x to the 7th? That's x to the 12th. That just so happens that they both matched, right? So remember, we're just adding exponents because you have 5 x's here and 7 more here. So we have 12 total x's. All right, last one. Kind of slightly getting more difficult each time. This one just has a negative in it. Let's do negative 4x to the 3rd times 2x to the third. So example 4, guys, is negative 4x to the third times 2x to the third. So do the multiplication with the coefficients. What's negative 4 times 2? Negative 8. And then how many total x's do we have at the end? 6 of them. Because we have 3 x's in the first and then 3 x's in the second, and then they combine to make 6. Is that all right? Okay, so go ahead and flip it over to the other page. What we're going to do next is come up with, basically it says look at these first problems. What's it called when you have a number in front and then you have like addition or subtraction behind it? What property do you have to use? Do you remember what it's called? Yes, distributive property. That's something that you kind of learn, but then you don't necessarily remember its name. You use it, but you don't necessarily call it all the time. So the distributive property is when you take a coefficient out front of either a sum or a difference, and you distribute him in. So that it becomes that coefficient times both parts separately. All right? So I kind of just wrote the generic there. So the distributive property means if you have this coefficient in front, say we have A in front of the sum B plus C, you could add B plus C together and then multiply by A, or it's actually the same if you multiply each thing by A and then add at the end. I actually just taught this in my Math 111 course this morning, and I told them, like, right now they're only dealing with numbers, like they don't know what a variable is. And I told them right now it doesn't make sense to use the distributive property if they're all numbers, like it's easier to do the addition and then multiply. But where you guys are going to use it is down here where we have a bunch of variables thrown in, so we can't add them because they're not like terms, correct? Like looking at number 1, can we add x plus 3? No. X and 3 are not like terms. So the only way we can kind of somewhat simplify is to distribute the 4 through.
So 4x plus 3. 4x is times 2, so it's going to be 12.
You got it. And then just whatever that sign is in between, inside your parentheses, it just matches it, right? So like, let's look at example 5, or 2, excuse me. Notice it has a negative, so it's going to stay a negative. So 5 times 3n gives us 15n, and then minus 40. Is that right, guys?
Yes.
Here, it gets a little bit more difficult because now we're distributing a variable, but it's what we just did on the front page. Remember when you multiply by a variable, you just add exponents, right? So what's 5 times 2? 10. And then what's y times y?
2. So it's going to be
Y squared. You got it. That's kind of how I think of it. You have 2 y's there, right? So you have y squared. And then anything times itself is just that thing, right? So 5y times 1 is just 5y. All right, next one, just be careful because we're distributing a negative through, which means we're going to change these signs, right? What's negative 8 times 2? Negative 16. And then how many x's total will we have? X to the third. And then what's a negative times a negative? Positive. And then 8 times 3 is 24, and that x just kind of tags along because he didn't have an x. Are there any questions there?
No, ma'am.
So we're basically unfactoring, and that's actually what the next lesson is. The next lesson is factoring. So it's like we're going back and forth. All right, so example 5 is a version of it, but then we have that x on the outside that we're going to combine at the very end. All right, so in order to combine these, we have to distribute the 4 first to both the x and the negative 6. Let that first x hang out. So we have x plus, what will that give us? 4x minus 24. Does that look right? So that first x is not part of the multiplication. You notice that? He's kind of just hanging out. And so it's just take this x plus whatever you get when you distribute that 4. But when I distribute that 4, I get 4x minus 24. So then what can we do at the very end? We can combine like terms. How many total x's do we have? Well, we have 2 terms that both have x. What's the coefficient of the first one? Technically what? A 1. So if we have 1x here and 4x here, how many x's do we have together? 5 x's minus 24. Is that all right? And that's what gets hard is because you're like, oh, I see x twice, so I want to make it x squared. That's only when you're multiplying. when you're adding and subtracting, it's merely saying I have 1 x-ray in this hand and 4 x-rays in this hand. How many total x-rays do I have together? I have 5 x-rays together. All right, so this last concept is, they call it FOIL. Have you guys heard of FOIL before? It's basically a way to remember how to distribute. So you have to distribute both the x to the x in the -6 and the 4, okay? So we're going to take him times both, and then we're going to take him times both, all right? So kind of a double rainbow going on, okay? So what's x times x? What is that going to give us, guys? X squared, you got it. And then what's x times -6?
-6.
And that's exactly how we say it. We always say that coefficient first. You can say x times -6, but that's weird. -6x is what you get. All right, so we're done distributing him. So we're going to turn around and do the same thing with the 4. What's 4 times x? 4x. And what's 4 times -6? -24. And once you do that, you just want to make sure that you combine things if you can. Are there any other x squares in that? No. So that's going to stay x squared. But we can combine this -6x with this 4x because they're like terms. What does that get us? How many x's? -2x, perfect. And then -24 is on its own. So FOIL, I don't know how many of you guys have heard of the word FOIL. It means first, outer, inner, last. And it's just a way to remind yourself. I don't like to force FOIL because some people are like, FOIL, what did it all mean? I'm like, just take that first thing, multiply it by everything in the parentheses. Even if there's 18 things in the parentheses, take that first thing, multiply by all of it, and then take the second thing and do the same. All right, so let's just make sure we can FOIL these bad boys. Example 7, guys, go ahead and FOIL x plus 3, the quantity, times x plus 5, and tell me what you get. Okay? X plus 3 times x plus 5. So take that first x and multiply him by that x and that 5, and then take that back 3 and multiply him by the x and that 5. And then you should be able to combine like terms to get a trinomial. If you get done with that, let's try 2x minus 3 times x minus 7. Looks like most of you guys are done with the first one, so I'm going to start working on it. I'll talk to the camera, but you go ahead and do example 8, okay? So I'll talk to the camera, and then we'll all reconvene and look at example 7 together. So example 8 was 2x minus 3 times the quantity x minus 7. All right, so when we do example 7, we're going to take x times x, which will give us x squared, and then we're going to take x times that 5 to give us a 5x. So we've officially distributed x to the x and the 5. Now we're going to move on to the 3. The 3 times the x gives us a 3x, and the 3 times the 5 gives us a 15. Once you distribute, you may or may not be able to combine like terms. I think on all of these guys, we're going to be able to combine like terms down to a trinomial. So on example 7, did you get x squared plus 8x plus 15? Does that look right? Okay, and then the only difference between example 7 and example 8 is that first guy has a coefficient of 2. Oh well, you know what I mean? We're going to double stuff now, but we're going to do all the stuff the same. So 2x times x should give you a 2x squared, and then 2x times a -7 should give you a -14x. Does that look right so far? And then -3 times x will give you a -3x. But then a negative times a negative will give you a positive 21. And like I said, more often than not, guys, you'll probably be able to combine those middle terms. And so we get 2x squared is at minus 17x plus 21. Does that look right, guys? Okay. So the next two, we'll do 9 kind of together, and then you can do 10 after we do 9. Sometimes when you're given binomials, they give them to you like this. N plus 7 squared. So the quantity n plus 7 squared. And what I want you to realize, and we kind of talked about it last week with square roots, n plus 7 squared doesn't mean square the n, square the 7. It means take all of n plus 7 and square it. So this is really n plus 7 times n plus 7, right? When you square something, it means take the whole thing and square it. Guys, at that point, FOIL like normal, okay? If you get done with 9, I'm going to have you go ahead and move on to example 10. 3a minus 4, the quantity squared. Once you do 9, notice 10 is really similar to it. It's a quantity squared, so we're going to take that quantity times itself twice, okay? 3a minus 4, the whole thing squared. You guys work on that. I'll talk to the camera. Example 9 is n times n, which will give you n squared. And then n times 7, which will give you a 7n. We've officially distributed that n to both parts. So we'll move on to the second 7. 7 times n will give you 7n, and then 7 times 7 will give you 49. At that point, you can combine like terms in the middle, and you should get n squared plus 14n plus 49. Example 10, we're going to do the exact same way. Do not square just the 3a and just the negative 4. We're going to square all of it. So this is really 3a minus 4 times 3a minus 4. All right? So we're going to distribute the 3a to the 3a. So 3 times 3 is 9. a times a gives us a squared. The 3a to the negative 4. 3 times negative 4 is negative 12. The a tags along. And then here, we're done with 3a, so we're going to distribute the negative 4. The negative 4 goes to 3a, and that gives you a negative 12a. And the negative 4 to the negative 4 gives you a positive 16. Does that look okay so far? And then more often than not, we're going to be able to combine those middle terms. So we get 9a squared minus 24a plus 16. Does that look right?